help me to record it. You may get a link of the recording, you may watch it, however, only I can download or edit the video. Basically download the video lah. Alright, I definitely could upload it later. Just in case lah, next time I tend to forget. If I forget to record it, you may help me record it first. Okay, now, for discharge per unit width, so another variables that we are going to learn is discharge per unit width. The word itself, discharge over width. So basically it's uppercase Q divided by the bottom width of the channel, which is B. Alright, so normally for rectangular channel, of course, the bottom width is the same as the top width. Alright, so discharge per unit width, the symbol used for discharge per unit width is lowercase q. So you have Q equals to Q over B. So you know that in this case, the unit for your discharge per unit width would be meter cube over second over meter. Alright, or you could rewrite this as Q equals to YV, since it is a rectangular channel, right? Okay. Of course, you are going to have, you can rewrite this as Q equal to YV. Let's show this, all right? I'm going to show this. How does it become that? People are still coming. Okay, you should be able to see my paper right now, guys?
Yes, doctor. Yes.
Okay, great. In that case, because my camera is auto adjust, so it keep adjusting it, alright? So I need to hold this down. Okay, now, just now in that case, right, where we have, when I say Q equals to discharge per unit width, what we have here is we also know that Q equals to AV divided by B. And what we have here is we also know that A is actually BY V divided by B. Alright, so you have that. Therefore, this would be equals to YV. Alright, alright, okay. What else? This is the case. Unit, of course, the unit, right? So the unit would be, you see, the unit for meter cube over second. This guy here is actually, let's do this, alright? The unit, you are going to have meter cube over second divided by meter. What you are going to have is the unit for Q would be this guy, or normally we are going to write this as this one here, or sometimes, all right, if I give you discharge, but I give you the unit of this one here, oops, it's still the same, because it has the same unit. You just cancel off another meter. All right, you'll get back this right here. All right, it should be the same. All right, so sometimes students tend to ask me, how come, it should be like this? No, all right. When you look at Wendy Chow's reference book, at times you will see this unit, all right? Okay, let's go back to our slides. Okay, you have that. Okay, look at this question. Water flows through a very wide channel at a rate of 2.5 meter cube per second per meter. It is very wide. There's the word very, right? I think I'm going to draw this. full screen. Let's see. This guy here, alright? Okay, sometimes the question say 2-meter wide channel. Don't assume it as very wide, unless it says, you know, there's a word very wide. It comes with the term very here, okay? Then, then you are going to have that lah, alright? The case of where, you know, if you have this guy here, what you can do is, I always need to full screen it, then you are going to have, if this is the case, you can use R equals to Y, okay? You can, that means you can replace lah, R is equals to Y. Now, okay. So of course, the question gives us discharge per unit width, which is 2.5 meter cube over second meter. Then the width of channel is 60, alright? And then this longitudinal slope or channel's bottom slope equals to 0.05, and then Manning roughness 0.013. Now, you know that you are going to use Manning roughness flow equation already, since Manning coefficient is given, okay, straight away. So the question asks us, what is the normal depth? Now, since this is a case of very wide channel, it simplifies things. It actually simplifies the whole question, because you don't need to find P anymore, because you can equate your R equals to Y, right? So for a very wide rectangular channel, right? Okay, if there is a question on this, I'll give you mark if you state R equals to Y. Okay, so therefore, okay, I can simplify my Manning equation. This is not Manning equation, but second one is, okay. The first one is the continuity equation. All right, the Manning equation, therefore, you see Q equals to, now in this case, right, all right, I'm going to show this. Actually, the Q is equal to A 1 over n r to the power of 2/3 s naught over half. And just a second, I'm going to write this for you. Okay, now, in this case, right, you have Manning previously, the Manning equation that you know is this equation, right? So, you know that since discharge over unit width is given where Q equals to Q over B. So for this expression here, both sides divided by B. So what you are going to get is, that means the left hand side divided by B, the whole term for the right hand side you divide by B. So therefore, what you are going to have is Q over B equals to, of course, not all it's just 1 over B, right? Everything 1 over B, right? So I'm going to rewrite this is the same, okay? So what I'm going to have here is discharge over unit width, okay, equals to, this would be, because a rectangular A would be BY. So what I'm going to have here left is Y, alright? So R 2/3 S naught over half. I further simplified this equation, alright? I further simplified this equation because I know that for very wide channel, alright, my R is almost equal to Y, so therefore I can further simplify it. It becomes Y over N, Y to the power of 2/3 S naught to the power of half. Of course, alright, of course, I know that, okay, I know that I can combine this guy, alright, because it has the same, it is the same variable. What I have here is Q, right, equals to, alright, so I put 1 over n first lah, alright, Y. If you multiply multiply the variables, of course the power you need to add them up together. This is to the power of 1, which is also equal to 3 over 3. So you combine them, you are going to have 5 over 3 as not half. It's simple as that, right? Okay. Now, the next thing that you need to do is you need to solve this guy here. I just put a note here. Actually, for Manning and Chasey, your y is actually y naught, which shows that it is the depth of uniform flow. Alright, so I'm going to rearrange this as a function of, y naught I have here, y over 3. Okay, so therefore I have qn over s naught half. Okay, this is provided, this is provided, this is provided. Of course, you can solve this guy. So once you calculate all this, right? Let's say what is the value here. Could one of you give me what is the value of Q, please? Anyone?
2.5.
2.5 is it? Okay. And
0.013.
okay, 0.013. Alright. S naught?
0.005.
30 ya?
5.
5, alright.
0.005.
Okay, 10 je. So I'm going to have that. Correct, eh? Okay, so to the power of half. So therefore, solving this, okay, I'm going to have, of course, once I solve, I have the value already of this. This is 3 over 5. Betul tak? Guys? Yes kan? Sebab the concept would be, correct eh? The concept would be you want to cancel this off, right? How would you do? Of course, you need to times 3 over 5 times 3 over 5, right? The whole thing, right? Am I right? So this becomes 3 over 5 lah, basically, yeah? Because this you will cancel off, becomes y naught, right? The concept is like that lah, alright? So I'm not going to write this. So therefore, you can solve your question correctly, answer directly, yeah? Solve for the answer. Alright, let's go back. So you have that, you present here. So therefore, solving it, your y naught should be 0.6272 meter. Alright, simple as that, eh? Okay. Now, the next activity, I think I changed this to your activity instead of exercise. Okay, the next activity will be involving a very wide channel as well. Alright, it says that the rate of flow is 6.5. See, it gives a rate of flow, but the unit, look at the unit, is meter cube over second over meter. Alright, so what you are going to have here is actually the discharge over unit width. The river has a width of 100 meter. Of course, it's a very wide channel. You are going to expect the width of the channel is huge. Yeah? The bed slope of 0.05, bending roughness 0.018. So what is the y naught? The same things, the same step you are going to use. All right. You see, what you are going to do is list out all the known variables. You are going to arrange. Either you can arrange it first, or you simplify it first. You know that for very wide channel, r equals to 1. Then, okay, so you change it. It becomes y lah, basically, but I didn't change it yet here. Okay, I think I changed it in this step here. Okay, so both sides divided by b, still you have y r to the power of 2/3 equals to qn over s naught. So r substitute with y naught because it is a very wide channel. So you are going to have y naught to the power of 5 over 3. Remember, this is coincidentally a rectangular section. So you can get your y not equals to 5 over 3. Just make sure you check, alright? 3 over 3 plus 2 over 3, you are going to get 5 over 3. And then qn over s dot. So substitute the known value, you are going to have, y not equals to 1.353. Actually, it seems like some of the exercises are repeating. Actually, these are for your practice, alright? So that's why I didn't give you the answer, alright, for you to practice on. Now, the next topic that we are going to look at today would be the best hydraulic section or most effective section. Sometimes it is also known as the most hydraulically efficient section. Alright, all these are the same, have the same meaning lah, basically. So what this best hydraulic section gives you is, it gives you minimum area for a constant discharge. Okay, we are going in this subtopic here. The analysis is to assume that our discharge Q is actually constant. Alright, it doesn't change. That means the depth of flow does not affect discharge lah. Alright. Referring to the conveyance channel, okay, we have learned the conveyance factor before, which is 1 over n times AR to the power of 2/3. This is for Manning. So for Chasey is different. You know that the meaning, the definition for conveyance, K is equal to Q over S naught to the power of half. Which is the carrying capacity over a unit longitudinal slope. You still remember that, I hope. So that's why you get this expression here. Alright, you know that already. Now simply, okay, for best hydraulic section, it gives you maximum discharge, maximum hydraulic radius, and minimum P. See, if the case of minimum P, right, okay, minimum, when P is minimum, of course your R is increases, alright? If P reduces, R increases, okay, because R is A over P. Now, if R increases, of course your Q increases as well, because K is actually Q over S naught half, right? So since they are directly proportional, right? So therefore, the concept would be, if you reduce R, okay, minimum P, your R increase, your conveyance increases as well. Alright, so that is the concept of most efficient section. So what are the advantages of having, when you design for best hydraulic section, if P minimum, when you want to line your drain, for example, either you are going to have your drain as concrete drain, or rubble mound, or whatever lining you have lah. Alright, of course, minimum P minimum shows, reflects that, right? The lining material or area to be lined is smaller, so therefore you can cut costs, right, for lining. Basically the construction costs, and then it also reduces the friction force, because as water flows, it actually is affected by the wetted perimeter. Okay, that's why the Manning roughness coefficient, the Chasey roughness coefficient, it is all based on the type of channels lining. Alright, the channels wall lining lah, basically. Alright, look at an example of rectangular section. Okay, A equals to 4.5. Okay, this slide shows an example of a rectangular section where the area is 4.5 meters squared. Okay, now this is a rectangular, so basically you have on the first column is the width, which I give you how many? 20 or 19 rectangular section here. The first rectangular channel has bottom width of 0.5. The second channel has bottom width of 1. The third section is 1.5. Okay. Now, when, as B increases, what you are going to have, your Y reduces with the same A. That means the constant A, which is 4.5, right? So your depth will be reduced to obtain the same A lah. Okay. So your P, okay, it is not, it is not reducing, but instead if you look at the value, right, it's reducing and increase as well. So if you plot it, right, to see how P varies with your depth of flow, this is the case. All right. So you are going to have that. All right. So the concept is, all right, you said you want to find the most efficient section. So you need to know, since the concept would be the P, the weather parameter should be minimum, right? So in this case, right, if you plot it out, you'll find the minimum P is 6 meter at depth of flow 1.5 meter and B equals to 3, which is this guy here. All right, this is a minimum P. All right, now can we prove this? Okay, because we said we want to design where we want to show that the most efficient section for A equals to 4.5 meters squared would have Y naught equals to 1.5 and B equals to 2Y naught. All right, that means 3 meter lah, 2Y naught. Okay, how does this comes to? All right, now that we have a standard formula where we actually have to differentiate lah. All right, okay. In this case, right, if you look at this table here, it is not the same as this table. Remember this table you learned early in, I think in chapter 1, okay, or early in chapter 2 lah, right, you have this. So let's compare. The top one is the formula for, the basic section, okay, of open channel. However, the bottom one is the best hydraulic section. Remember, just now when we plot this, right, we show that, minimum weather parameter occurs when the B is actually 2 times Y naught. Okay. Now, in this case, let's look at this. The best hydraulic section, right? Rectangular. If you look at this, your B, all right, your flow area. Let's look at this. You can actually get it back. Your A is 2Y squared. Your P is 4Y. You know that your A is actually B times Y, right? Okay, so therefore your B is actually 2Y. Okay, P is actually B plus 2Y. Okay, so therefore you get 4Y. Alright, your top width for rectangular channel, of course, is equal to B, right? For rectangular section. So B is actually 2Y. It shows here, alright? These are the formula for best hydraulic section. For trapezoidal, okay. For trapezoidal, you have to be careful. There are two different cases. The first case where it asks you to find best hydraulic section, but it says you can use any side slope. Therefore, your formula is not going to be like this. This formula that is given in this table only applies if your side slope is 1 over square root 3. Okay, be careful, your z is equal to 1 square root 3. Then you'll get this formula. If the case where it says it's fixed the hydraulic, the side slope z as, for example, 1.5, then this formula will change as well. Okay, except for R lah, we are going to look at it later. Okay, so be careful. Okay, there are two cases where when the question asks you to solve for best hydraulic section, it gives you a Z, all right, and there's another aspect where the question allows you to use any Z. Of course, the best Z that you want to use will be 1 over square root 3 lah, all right? That will give you the best hydraulic section, all right? For triangular section, side slope is 1. That means 45 degree, 1 to 1. Okay. So of course your triangular will be 90 degree the vertex angle. Okay. So therefore, you know that flow area, if your Z is 1, your flow area, which is in previous slide, right? ZY squared, right? Since Z is 1, therefore, of course, your flow area will become Y squared. The same thing, for all the other. Semicircle as well. These are the formula, right? And then parabola as well, right? I give you more with the parabolic one because actually we seldom ask about this question, but I think this is important for you to know as well. If you ask me, do you have to memorize all this? No, you don't have to. Okay, but of course, our exercises will guide you through how does this, formula come to, all right, into this table lah, basically. How do you get all this formula? Okay, let's form the best hydraulic section for rectangular channel. Okay. Now, rectangular channel, of course, this is the typical section. You have bottom width, which is the same as the top width, T. T equals to B, and then the depth of flow Y. Okay, the flow area is A equals to BY. P is B plus 2Y. B plus Y plus Y. Okay, 2Y. The concept is you want to make P minimum, right? Okay. So you need to set dp over dy equals to 0 because you want to set P minimum. Okay, you know that your A is constant, so you have to include your A in here. Alright, so that means you have to rewrite the P expression in terms of A and Y. So what you are going to do is, okay, for best hydraulic section, dp over dy is 0. Okay. Because I believe when you differentiate one more time, you're going to get a positive value which shows that the P is minimum. This is all the concept of mathematics you should have learned it earlier, alright? We know that, okay, assume A to be constant, alright? So rewrite this, B equals to A divided by Y, substitute in P, okay? When I substitute B equals to A over Y, I'll get this expression here. Okay, so differentiate it. Differentiate P with respect to Y. So I'm going to have dP over dy. If I differentiate A over Y, A is constant, so it remains there. So I'm going to have -1 times A over Y squared. Okay, that means it is initially -1, right? Okay, the power, so I have to minus 1 again, okay, as the rule of differentiation. So I have -A divided by Y squared plus 2. Okay, because you differentiate 2y, it becomes 2. Actually, this one, okay, if you are so used to, doing A y to the power of -1, you could do the same. That means -1 times A times y to the power of -2. When you rewrite it, it becomes divided by y squared lah. Alright, it's still the same. Okay, I hope you still remember your differentiation technique, Alright. So for best hydraulic section, okay, this equal to 0, right? Okay, this term dP over dy equals to 0. So I'm going to rewrite that, okay, plus 2 equals to 0. I put subscript E to show it is effective section, Alright. So therefore, rewriting it, that means I bring this over, okay, and then the y squared, I bring it, so I have A equals to 2y squared. I remember the table just now, alright, the best section table for rectangular section, it does give you A equals to 2y squared, right? Okay. So then you know that A is also equal to BY. Okay, the typical the typical flow area, alright? So you have BY equals to 2y squared. So you are going to get B equals to 2y, alright? 2y lah. I don't mind if you skip the subscript E, alright? I just want you to show just one wanted you to know there's difference between Y naught, YE, and YC. Later, in the third chapter, we are going to learn about critical depth of flow. So, therefore, okay, this is the typical vector parameter formula. Okay, now you know that for best section, your B is actually equal to 2Y, so you can substitute it. So you are going to have P equals to 4Y. Okay, and then R is A divided by P, so therefore you are going to have R equals to Y over 2. Alright, so that means we come to the conclusion of Bruce table lah, right? Which is this guy here, alright? This guy, alright? You are going to get all this, alright? Okay, section factor. You still remember what is section factor? Okay, it has to do whether with whether you are using Manning or Chesy equation. I hope you still remember it, alright? That means section factor would be AR to the power of, for Manning, AR to the power of 2/3 equals to QN over S naught to the power of half. Okay, that is section factor. That means the definition will be the term as a function of the term which is written in a function of Y. Alright. I hope you remember those. Okay. Sorry, I think I go quite fast earlier. Alright. So going to close. Okay, now I'll skip this because this is repetitive and what we have learned. I already explained, right? You can show, even when you plot it out, right, as the width changes, right, with the constant A, all right, it will show you the minimum P is, for this case, it shows that B equals to Y, basically, which is the minimum. Actually, if you differentiate again, this is dP dy equals to 0. If you differentiate again, dP d squared P over dy squared, right, you are going to have a positive value which shows its minimum, alright? That is the rule of thumb of it. Okay. This activity, the question says, okay, show that the best hydraulic for trapezoidal section, okay, best hydraulic trapezoidal section is actually half of a hexagon. You know how many sides does a hexagon has? Anyone? Hexagon ada berapa sisi? How many sides does one hexagon has?
6.
Okay, great, correct, 6. Right. So if you have half of it, okay, you are going to get a trapezoidal section, right? Which is this one. If your slide, I'm not sure whether I give you the correct slide or not. Of course, initially last time I wrote this 60 degree. Of course, if you look at this, it's already, more than 90 degrees. So it's wrong. It should be 120 degree. Now, this is for best hydraulic section. Okay. You can show this, all right? Z equals to 1 over square root 3. Okay, since this is 120 degree, you can use trigo function to get that. Okay. Now, before this, you want to prove that best hydraulic trapezoidal section would be equal to this guy here, where the Z is actually half 1 over square root 3. Okay. So how do you prove this? The same step, where you are going to differentiate P with respect of Y, you get dP dy equals to 0. However, there's another step. Okay, you also have to differentiate with Z. Okay, let's look at it, because you are going to get the best Z. All right, for the best hydraulic section. Now, what is the Z, right? So let's go to this. For a trapezoidal section, the flow area is given as by plus zy squared. Maybe sometimes you will ask me, is all this derivation important? It depends. Sometimes the question asks you to prove it. Okay, gives you the formula and asks you to prove for best hydraulic section. How did you come to that formula? So in this case, it's important lah. Right. So vector parameter is P plus 2y squared 1 plus z squared. Then rewrite. You say A is constant, right? we want to substitute the B, right, in P. So rewrite the flow area equation expression. So dP over dy is equal to 0. Okay, this is, I'm rewriting this. I say I bring zy squared over, so I have by equals to a minus zy squared. So I bring y over, so I have b equals to ay minus zy squared. I'm explaining to you this step, but you really have to write it down so that you have a feel of it. How do you, rearrange all this formula? Try it out, right? Because since I'm always letting you off early, right? You have ample of time to try it out. So substitute B in method parameter. So you are going to have this. Okay, I know that sometimes the expression is quite long, but if you take your time, it's not difficult at all. Comparing with when you need to solve, partial differential equation is more difficult. This is just, simple equation, right? So method parameter, you have rewritten it in terms of A, Z, and Y. Okay, in this case, all right, first, what we are going to do is we are going to assume A and Z to be constant first. It's just too much if we have, two dynamic variables. What you are going to assume is A and Z to be constant. Okay, so differentiate P with respect of Y. So you are going to have dP dy equals to negative A over Y squared minus, of course, when you differentiate Z and Y, it becomes Z lah, plus, since square root 1 plus x squared is also a constant, 2 is also a constant, times y, so you are going to have that term only. Okay, so set dP dy equals to 0. So you are going to have your best section. Okay, when you set it equal to 0, you are going to have this, alright? So therefore, rearranging the expression, you are going to have A equals to, in bracket, 2 square root 1 plus x squared minus z times y squared. Now, just a second, I'm going to flip back to this formula. This guy here. Look at the trapezoidal one. Okay, I'm going to stop this. Okay, this trapezoidal guy. Right, this trapezoidal. You see the formula of our area. Just now what we found, that is y squared in bracket, I forgot already. Okay, in bracket those terms lah, alright? That means you're going to have in bracket 2 square root 1 plus x squared minus z. Okay. Now in this table you have square root 3y squared. Why is there the difference? It is because you have substituted the z to be equal to 1 over square root 3. Just now we have not found this the most efficient z yet. Now therefore that A, okay, that you found actually, this A actually should be used when your z is not equal to 1 over square root 3. This is the formula. That's why I put the red box, alright, around it, because this formula is important too, and I'm sure you know how to get it. It's just, simple differentiation, and it'll get you to this expression here. If, just now I mentioned, if the question give you use a constant z, for example, 1.5. So you are going to substitute z equals to 1.5. You are going to get your new expression for A, for the most effective section lah, when z equals to 1.5. But if only z given, if z is not given in the question, of course you are going to use z equals to 1 square root 3, 1 over square root 3. then you are going to find, your A, right, to be equal to square root 3y squared, right? You simplify there. This, I hope you understand so far. Stop me if you need further explanation. Remember that. Okay. Okay, subsequently, this is the same expression as P. All right, I just rewrite it. Okay, so I substitute the A. Okay, I substitute the A. So simplifying it, I'll get this. Okay, because I actually have I simplified the whole thing lah. Okay, I substituted this. Try it out. You are going to get this. All right. Okay, then I factor to y. I factor to y. I'm going to have this term, right? This I cancel. It becomes y. All right. They are the same terms. Okay. Right. Therefore, a over p. You see, you find this p, the term a. We can cancel it out, this is the same term because it's multiplication. Of course, you can cancel this, and then what you are going to have is y over 2. That's it. Okay, simple as that. It actually turned out the same as when you use z equals to 1 over square root 3 too. All right, the same formula. So r is equal to half of y. Okay. Now, if z is allowed to vary, what does it mean by z allowed to vary is if the question doesn't give you z, okay, it asks you to use the best z, then you are going to use z equals to 1 over square root 3. Now, how do we prove that z equals to 1 over square root 3 is the best z? So, this is this is where we are going to prove it. Okay. Now, if z is allowed to vary, you still remember this formula comes from this guy here, all right? Okay, I just continue, all right, to differentiate. I'm going to differentiate z. Okay, if it allows to vary, okay, I have that. Of course, rewritten this. Okay, I have y equals to square root a because I make y becomes the function square root a divided by 2 square root 1 plus z squared minus z. This is just rearranging it. All right. So I have that. Substitute this into p. All right. This is a p. This is the p that we found from here. This guy here. All right. This is the guy. All right. So substitute it. All right. There you are going to have. Look at this. Your p is actually in terms of a and z because you are going to differentiate p with z right now. Okay, so what you are going to have is, okay, so simplify, you can cancel this out. Okay, cancel this out, but it becomes square root here because this is 2 over 2, this is 1 over 2, so you are going to have half. That's why you have here. All right, so differentiate p with respect of z. Okay, this is how you differentiate it. I'm not going to explain it, but keep in mind that your a is constant, only z changes. All right. All right, so I have that. Of course, when you differentiate it, of course, the whole thing lah. All right, to the power of half. So you have 2 maintain 2, power of half, then minus 1, you have minus half lah. Okay, because of minus half, then you differentiate again inside. All right. Inside the bracket, you know that this is in bracket to the power half, right? So differentiate inside the terms inside the bracket, so you are going to have this. All right. So therefore, when you set dp over dz equals to 0, you are going to get the z value lah, basically. Okay. I think I simplify it further. All right. I simplified it further, so I have that. I make dp dz equals to 0. Okay, so I have those. Okay, you just follow the steps, right? So I kind of solving all this lah. Solving all this, you just rearrange all this. You are going to get z equals to square root 1 over 3. Okay, that proves it. It's actually, let me tell you this. I purposely put a lengthy procedure because I go step by step. If you can solve it faster, if you look at this, you can straight away you get this, then you can skip all this, right? I just want you to, I don't want you to have problem on how I solve this, right? Asking me how does this come to this, so that's why I put more steps in it, right? So therefore, z equals to 1 over square root 3. Of course, square root 1 becomes 1 as well. So I can rewrite this as 1 over square root 3. So when z is equal to 1 over square root 3, I substitute in earlier, then this can be simplified into 2 square root 3y. So what becomes of b is this. What becomes of a is square root 3y squared. This is the value in table where z equals to 1 over square root 3. Remember that, Okay, I think these are all the exercises. I'm going to stop here. You try this out. Okay, for this activity, there are part A and B. A is basically you cannot use the expression from the table. B you can use the expression from table. Why? For B you can use z equals to 1 square root 3, but for A your z should be 1.5. Alright, therefore for A, right, what you have to do is you are going to use this A, alright, and then this Y. I don't think so, you need to find B. For example, for Manning, right, because your Manning will be just A and R, right. This already we simplify it, we take into account of A and B, we have simplified into R, okay. So therefore, I hope you can try this out, alright. So I'm just, since we are recording this, right, this activity, right, I'm just going to flip through so you get, this will be recorded as well. At least you get the answer, right? You can actually double check it, when you do all this, right, I hope that you won't look at all your solution first before attempting to answer all those, alright? So we are going to have that. This is the A, B. It's similar, all these are trapezoidal. I think I've been repeating. I purposely give you more questions, right? Okay, this is different. Okay, so that is for our class today. Do you have questions so far? Guys?
No, no, doctor.
Okay, no. Are you guys sleepy already? Too early.
Yeah, I'm here. Don't worry, doctor.
Yeah, okay, that's good. Oops. Oops. Oh, what happened? Okay then. If you don't have any question, we'll continue next Monday then. Is it okay?
Okay, doctor.
Okay, doctor.
Okay, doctor.
Alright, okay. So
Okay, doctor.
make sure you attend all those activities,
Okay, doctor.
Alright. Okay, see you guys.
I try my best, doctor.
Okay, that's good to know, Haris. Okay, bye-bye.
Okay, thank you,
Thank you.
doctor.
Thank you,
Bye.
doctor. Bye.
Thank you, doctor.
Bye.
Thank you, doctor.
You're welcome. Do you guys have any more question? Awati?
Doktor, saya ada soalan.
Okay, yeah.
Sekejap ya, Doktor.
Boleh. Yang lain ada soalan ke? Ke nak semua pun nak tunggu Awatif?
Nak tunggu soalan Awati.
Okay, Yuslan.
Doktor, yang apa? Yang tentang trapezoidal section tu, yang formula dia for a trapezoid tu. Slide 2.23.
2.23. Aktiviti
Aktiviti.
Sekejap ya, saya tengok. Aktiviti nota U kan 2.23 kan? Okay, saya flip through tengok betul tak, sebab nota I ni lari sikit. I tak sempat, selalu terlupa nak ubah. Kita tengok dulu, saya present dulu. Yang ini ke? Kejap, belum lagi. Yang ini ke Awatif?
Bukan, yang ada hexagon tu.
Hexagon, okay, saya faham. Okay. Hexagon. Yang ini. Betul? Awati, betul? Okay. Awati tak payah turn off lah, tak payah mute. Sebab kita berdua juga, yang lain nak dengar juga. Okay. Alright, okay. Soalan Awati ialah?
Saya tak apa nak faham kat dia punya formula.
Okay, konsep dia kan macam ni. Konsep dia, okay. Saya pergi pada sini konsep best section ni ialah Q maximum, P minimum. Kalau P minimum, of course kita akan dapat Q maximum lah. Okay, boleh Awati? Konsep dia P minimum. Bila P minimum, okay, sebenarnya graf ni dah tunjukkan macam mana kita dapat P minimum ni, di mana kita differentiate dP over dy. Kalau you tengok perbezaan P terhadap perbezaan Y kan dekat point dP dy sama dengan kosong ni, sebabnya ialah titik minimum, iaitu perbezaan P terhadap Y ialah kosong. Lepas tu dia berubah naik balik kan, lepas dia turun dekat point sana, perbezaan tu tak ada, lepas tu dia naik balik. Situ ialah point dP dy sama dengan kosong. So you akan dapat P minimum dekat titik tu boleh Awati? So kita punya konsep ialah kita nak dapatkan P minimum. Jadi kita kena set dP dy sama dengan kosong. Itu boleh alright. So sebenarnya benda step yang sama kita juga gunakan untuk dapatkan formula best section untuk keratan segi empat. Tapi aktiviti ni yang 2.18 dalam you punya slide ialah kita nak dapatkan keratan yang terbaik untuk keratan trapezoidal. So macam mana kita nak dapatkan keratan terbaik ni ialah sebabnya kita dah tunjukkan kata trapezoidal section ni sudutnya 120 darjah di mana di mana kecurunan sisi heksagon ni ialah nisbah 1 per square root 3 lah, 1 nisbah 1 per punca kuasa 2 3, alright, dah kurang 3. Okay, now sebab kalau you cari balik dengan sudut 120 darjah ni, Z ni akan dapat 1 per square root 3 lah okay, itu you dapat buktikan. Jadi sekarang ni dia nak, soalan ni nak you tunjukkan untuk keratan berkesan yang paling berkesan untuk section trapezoidal ni, you kena buktikan Z tu sama dengan 1 per square root 3. Jadi kita kena teruskanlah sampai dapat Z sama dengan square root 3. So untuk keratan trapezoid, A ialah BY plus ZY squared. Konsepnya ialah you nak cari dp dy sama kosong kan? Okay, you tengok kalau you ada B sebenarnya you kalau boleh, sebab you kata konsepnya you biarkan A constant. Jadi P ni you kena tulis dalam sebutan A dengan Y sahaja. Tapi in this case ada Z jugalah. So A, Y, Z. The first step ialah you kata A dengan Z adalah malar, iaitu constant, tak berubah. Okay. Jadi sekarang ni macam you nak gantikan B ni dalam sebutan A dengan Y. So that means formula A ni you kena tulis semula di mana you jadikan B sebagai tajuk rumus. Okay. Bila B sama dengan tajuk rumus, formula A ni akan jadi B sama A bahagi Y per ZY. Awati, saya nak tanya, setakat ni ada masalah tak?
Setakat ni faham lagi.
Okay,
Yang
faham.
doktor dah explain balik ni.
Okey, jadi bila kita kata nak gantikan P ni, kita gantikan teruslah dalam P, mata parameter. So persamaan dia macam tu kan? Kita dah ganti B. Sebab A per Y tolak ZY ni ialah B kita. Okey, dah ganti. Sekarang ni kita kata A dengan Z ni pemalar. Jadi kita boleh differentiate dP per dy. Sebab kita kata target kita nak cari nilai bila dP dy sama kosong. Okay, so kita kena differentiate lah. Kita kena bezakan dP terhadap dy. Jadi so bila sampai pembezaan ni ada masalah tak? Pembezaan ni?
Tak.
Tak ada masalah
Okay.
Tak. Okay, sebab kalau rasa susah sangat A bahagi Y, awati boleh tulis balik A darab Y kuasa negatif 1 kan? Sebabnya nanti dapat balik lah benda yang sama. Okay, alright. So kita set lah dP dy sama dengan kosong. Jadi term ni sama dengan kosong. Betul So kita nak tengok apa persamaan bagi A. So kita tulis balik dengan A dijadikan tajuk rumus. So setakat ni ada masalah tak dapatkan A?
Tak ada doktor. Tapi kiranya kalau nak jawab soalan ni, kiranya kena tulislah formula dia tu daripada awal sampai dapat pemalan.
Okay, macam ni. Kalau you tak boleh ingat formula ni, A sama dengan dalam kurungan 2 square root 1 plus Z squared minus Z Y squared ni, you kena buat balik semua ni kalau tak ingat. Okay, sebab jadual yang kami akan bagi tu, saya tak pasti nanti you kalau boleh awati tanya saya balik sebelum final exam ataupun test, adakah formula ni akan diberi. Sebab yang pasti jadual bila Z sama dengan 1 per square root 3 tu jadual yang keratan paling berkesan tu saya akan bagilah jadual tu. Dua jadual tu saya akan bagi, iaitu jadual yang formula yang biasa dan juga formula untuk keratan paling berkesan. Yang tu saya akan bagi. Tapi formula ni mungkin awati tanya saya balik nanti. Okay. Tapi saya akan bagi tahu lah kalau perlu. Saya akan bagi tahu. Normally saya bagi tips lah. Okay. Nah, ingat tak soalan yang saya suruh cuba tadi? Dia ada dua. Satu dia kata Z ialah, dia bagi 1.5 yang tadi. Saya pun tak ingat. Z tu dah diberi. Lepas tu bahagian B tu dia kata guna je Z mana-mana kan. So nak selesaikan bahagian A tu, you kena guna formula ni tau. Sebab A yang dalam jadual ni, yang diberi ni, okay, contohnya yang ini kan, hilang. Okay, ni. A ni ialah berdasarkan kalau Z dia sama dengan 1 per square root 3. Betul tak? Dia dapat ni kan?
Betul.
Itu pun kalau you gantikan gantikan Z sama dengan 1 per 3 dalam persamaan ni. You baru dapat A sama dengan square root 3. Y square lah. Okay. Kalau Z you bukan 1 per square root 3, you takkan dapat tau A sama dengan square root 3 Z, A sama dengan square root 3 Y square. Jadi you kena hati-hati Selepas tu, okay, selepas step ni, saya nak, ni kan P sama dengan AY ni kan. Saya nak gantikan A ni sama dengan keratan berkesan A ni. So, saya masukkan lah, saya gantikan. So, bila saya gantikan, saya akan dapat persamaan ni lah. Awak cuba masukkan A sama dengan dalam kurungan square root 1 campur Z kuasa 2 tolak Z Y square. Ataupun saya tulis. Saya boleh tuliskan benda ni. Tapi saya rasa saya perlu formula tu sebab saya okay, saya dah jumpa yang ni. Saya tunjukkan. Okay. Nampak kan? Awak tu kan?
Nampak doktor.
Okay, jadi tadi kita kata kita nak P, kita kata kita dah dapat A sama dengan 2 square root 1 plus Z square minus Z Y square. Saya tak tulis D lah Okay, jadi faham-fahamlah dia efektif Jadi P ni ialah A per Y. Ni yang dapat dari tadi kan, awal-awal tadi kan? 2 Y. Saya sengaja Z ni saya palang sebab kadang-kadang confuse dengan 2 ni kan? Jadi saya letak macam tu. Sebab kadang-kadang saya akan confuse dengan 2 ni. Okay, gantikan A dalam sini. Alright. So saya ada P sama dengan saya ada 2 Y square bagi Y tolak Z Y. Okey, tengok sekarang ni saya akan dapat, betul kan? Jadi saya akan dapat Y ni saya kena darab masuk, ini pun kena darab masuk kan? Jadi saya ada 2Y 1 plus Z kuasa 2 tolak ZY tolak ZY tambah 2Y 1 tambah Z kuasa 2. Saya boleh campur tak 2 ni? Yang ni dengan ini kan? Saya akan dapat boleh kan? Jadi 4Y 1 plus Z kuasa 2 tolak 2ZY. Saya dah permudahkan kan? Jadi saya faktorkan 2Y sebab saya boleh faktorkan 2Y kan? Keluar saya akan dapat 2, ni akan dapat 4Y kan nanti? Jadi 1 plus Z kuasa 2 tolak, tinggal apa? Z sajalah. Dapat tak balik formula tadi? Boleh? Formula tadi dapat balik kan? Yang P sama 2Y kan, yang saya gantikan tu kan. Sekejap saya tutup ni dulu. Saya pergi balik slide kita.
Dapat doktor?
Kan, itu yang nak tunjukkan. Sebab tu kadang-kadang saya suka you try cuba sendiri tau. Untuk bila saya cerita-cerita tu, kalau boleh cuba sendiri. Kita tengok balik slide kita. Okay. Yang step, tak apa, ini pun saya record ni. Nanti saya share dekat kita. Tengok tadi proses yang saya tunjukkan ialah daripada ini, bila ganti A masuk sini, you akan dapat ini, kan? Yang bawah ni, P sama 2Y dalam kurungan K. Now, you nak, bila nak cari R, hydraulic radius ialah A bahagi P. Perasan tak, term ni, you cancel dengan term ni, you akan dapat Y squared bahagi 2Y. So, you cancel Y, you akan dapat Y per 2. Betul tak? You akan dapat ini.
Betul doktor.
Betul So, setakat ni tak ada masalah kan untuk faham kan?
Tak ada.
Okay, so dah selesai yang itu. Okay, so formula ni you boleh guna tau. P sama 2Y, A sama ni, R sama, tapi P ni sebenarnya you tak payah guna pun kalau you nak selesaikan persamaan Chasey atau Manning, sebab Chasey dengan Manning hanya A dengan R kan. Kadang-kadang kalau R tak diberilah you baru perlu cari P kan. So sebenarnya ringkas je, maknanya contohnya soalan A tadi, gantikan Z, nilai Z dalam persamaan ni, nanti A you ditulis dalam sebutan Y, sama juga R dalam sebutan Y, sebenarnya dah boleh selesaikan untuk Y pun. Itu sebenarnya senang je. Cuma bila saya derive formula ni, you akan nampak pening lah sebab banyak formula kan. Okay. Jadi kalaulah, kita sebenarnya bersambung tau, bersambung. Tadi kita kata Z yang ini persamaan ni boleh pakai untuk mana-mana Z, termasuk Z sama dengan 1 per square root 3. Okay? Tapi sekarang ni, you nak tunjukkan yang terbaik, Z yang terbaik ialah 1 per square root 3 kalau Z tak diberi. Z mana you nak guna ialah 1 per square root 3. Macam mana kita nak tunjukkan itu? Sebab soalan ni disuruh you prove the best section of trapezoidal would be half of hexagon. Maknanya bila hexagon, Z tu sebenarnya 1 per square root 3. Jadi saya start dengan kalaulah Z dibenarkan berubah, maknanya kita nak cari Z terbaik lah maksud dia kan. Okay. So ini formula yang saya salin dari tadi tau, yang kita dah tunjukkan, yang saya buat dalam kotak merah tu kan. Okay. Jadi saya susun balik. Saya jadikan Y ni sebagai tajuk rumus. Jadi A bahagi term ni punca kuasa 2. Saya dapat ini kan, betul?
Betul.
Okay. Lepas tu masukkan term ni dalam P kita tau. Ni Y ni masukkan. Ini P yang kita cari tadi kan? Sebab sekarang ni saya nak DP DZ pula. Sebab saya nak dapatkan Z yang terbaik lah basically Maknanya Z dibenarkan berubah. Jadi saya nak dapatkan P minimum juga. Jadi saya DP DZ. Konsep dia macam tu. Sebab kali ni Z pula yang berubah. So jadi saya masukkan Y ni. Jadi dia akan jadi 2 punca kuasa 2 A bahagi 2 square root 1 plus Z squared minus Z dalam kurungan 2 plus 2 times square root 1 plus Z squared minus Z. So saya akan dapat macam ni. Betul kan? Okay. Daripada sini tahu tak macam mana dapat sini? Ini. Boleh?
Yang ni.
Yang ni saya tunjukkan lah saya tulis, boleh?
Boleh doktor.
Okay, saya tunjukkan. Nampak screen saya dah kan?
Nampak?
Okay, so saya kata saya nak tunjukkan yang itu. Jadi okay, sini. Jadi tadi kita ada P Sebenarnya kalau boleh yang ni kurungan jugalah lebih selamat. Jadi 2 tolak tengok kalau saya buka saya kata 2, okey. A ni kuasa setengah. Dari bawah ni ialah ni pun kuasa setengah, betul tak? Itu maksud dia kan? Sebab punca dia bergerak. Okey. Ini betul logik daripada persamaan ni kepada ini. Boleh kan?
Betul doktor.
Okey.
Boleh.
So, betul. Jadi yang ini ialah 2 1 tambah Z kuasa 2 tolak Z. Yang ini sebenarnya kuasa 1 kan? Betul tak? Benda ni kuasa 1. Jadi sebab saya nak jadikan pembawah dia sama, saya bagi dia 2/2 lah, 1 juga. Betul kan? Okey. Persamaan expression ni sama tak dengan expression ni? Kalau kita kata kita nak gantikan benda ni B, the whole thing B, ni pun B kan? Ni B kuasa 2/2, ni B kuasa setengah. So kalau hasil bahagi, kuasa dia you tolak kan? So you akan dapat 2 A kuasa setengah. Ini you akan dapat 2 1 plus Z kuasa 2 tolak Z kuasa setengah. Betul? Ini jawapannya. Sebab 2/2 you tolak setengah, you dapat setengah lah.
Betul.
Okay. So, saya tulis balik. Kan? Sama je kan? So, saya boleh gabungkan sebab kuasa yang sama. Tengok sama tak yang saya gabungkan? Betul lah tu. Kan? Dapat balik kan?
Doktor dapat balik.
Okay. So, kita dah faham ke setakat ni Okay. So, kita balik pada slide kita tadi. Okay. Jadi, dah tahu macam mana daripada yang punca tu dapat yang simplified, dapat yang P ni kan, dah dapat. Kemudian the next step, kita kata kita nak P minimum kan, okay, terhadap Z kan, sebab kita nak tahu juga Z tu macam mana. Kalau Z berubah, Z mana yang akan bagi P minimum. Jadi kita kata dPdZ. Okay, maknanya kita differentiate dPdZ ni. Okay, konsep dia ialah ni nak saya tunjukkan juga nak Awati nak saya tunjukkan ke Awati boleh buat sendiri? Tengok 2 kekal, betul tak?
Betul.
Term ni sepatutnya kuasa setengah kan? Kuasa setengah, kuasa tu bawa ke depan kan? Setengah darab. Okey. Bila kuasa setengah, kalau you dah bezakan, dia akan tolak 1 kan?
Betul.
Jadi setengah tolak 1 dia akan dapat negatif setengah kan?
Betul doktor.
Jadi maknanya 1 bahagi punca lah dia akan dapat ini. Okey, ini ialah kita hanya selesaikan yang luaran. Dalamannya macam mana pula? Okey, yang dalaman ni you akan ada, kalaulah A ni saya darab masuk lah, maknanya 2A square root 1 plus Z squared minus AZ lah katakan So the first thing would be saya bezakan yang dalam ni. Setengah darab, depannya ada 2A kan? 2A maintain. Sama juga saya bezakan square root 1 plus Z squared, dia akan jadi, dia ada negatif setengah, tak ada. Dia ada setengah je, punca 1 plus Z squared. You dah bezakan yang ni, you akan dapat negatif A. Betul? Ini sebab you bezakan dalam ni lagi 2Z. So that means you akan ada darab 2Z. Lepas tu you bezakan yang ni negatif AZ, you akan dapat A. Boleh?
Boleh.
Okay.
Boleh doktor.
So boleh.
Boleh.
Jadi you cancel 2 ni, soalnya you mau dimudahkan tau, you cancel 2 ni, you akan dapat apa ni, A, you akan dapat, you boleh mudahkan tak? Minus tak, you tak mudahkan. Okay, tak apa. Okay, you akan dapat persamaan ni. Okay. Ini yang dari tadi lah kan. Jadi pengatas ni saya akan darab je lah ke atas ni kan. Saya akan darab ke atas ni. So sekarang ni saya kata nak dapatkan nilai Z ni bila P minimum. Jadi saya set di P di Z sama dengan kosong lah. Okay, kalau saya set di P di Z sama kosong, okay. Kalau term ni saya bawa ke sana, term ni akan jadi kosong tak?
Kalau yang tu bawa ke belah kanan.
Kosong kan? So tinggal yang pengatas je kan? Tinggal pengatas je kan?
Betul.
Okay, tinggal pengatas ya. Okay. So ni pengatas je kan? Okay, sama kosong kan? Okay. Jadi A ni saya bawa ke sana. Jadi A kan? Jadi punca boleh setakat ni
Boleh.
Maknanya 2AZ bahagi punca 1 plus Z squared minus A. A saya bawa ke kanan. Jadi kemudian pembawah ni saya darab dengan Z. Okay. Tapi sebelum tu dua-dua belah ada Z, A saya boleh cancel lah. A tinggal satu lah kan. Kalau saya A ni bawa ke kanan, A bahagi A dapat 1 kan.
Betul.
Jadi saya bawa pembawah dia ke sana, darab 1, maintain square root 1 plus Z squared. Okay. Ni yang saya cakap step by step ni. Okay. Jadi sampai sini kedua-dua belah kiri dan kanan saya kuasa 2 kan. Kalau saya kuasa keduakan sebelah kiri, kita akan dapat 4Z kuasa 2. Betul Kalau saya kuasa 2kan sebelah kanan, saya akan dapat 1 tambah Z kuasa 2. Setakat ni boleh
Boleh doktor.
Jadi 4Z kuasa 2 tolak Z kuasa 2. Ini saya bawa pindah ke kiri, saya akan dapat 3Z kuasa 2 sama dengan 1. Yang 3 ni saya bawa ke kiri, saya akan dapat Z squared sama dengan 1/3. So Z sama dengan punca, sebab kalau saya nak hilangkan kuasa 2, saya mestilah darab dengan setengah kuasa dia kan. Jadi tinggal Z, maknanya ini pun punca lah, ataupun kuasa setengah lah 1/3. Disebabkan kita tahu kata punca 1/3 juga sama dengan punca 1 bahagi punca 3 kan. Dan punca 1 ni pun 1. So kita dapat tunjukkan, buktikan Z sama dengan 1/√3. Itulah, selesai lah. Boleh?
Boleh doktor, faham.
Okay, faham Alright.
Faham.
Sama-sama.
Terima kasih doktor.
Sama-sama.
Doktor satu lagi.
Ya, Maizato. Yang mana?
Yang dekat table best hydraulic section tu.
Okay, alright. Kita pergi sana kejap
Okay.
Ini
Kan maknanya kalau macam kalau Z tu diberi, so kiranya kita bukan pakai formula yang dekat table ni lah.
Betul. Tak boleh sebab formula A dia dah lain. Formula A dia you dapat punca 3 Y kuasa 2. Kalaulah Z dia tu you ganti dengan 1/√3. Kalau you tak gantikan, kalau Z dia you guna nilai lain, you takkan dapat ini. Betul Maizato?
Oh, kiranya pakai formula yang dalam kotak yang dekat soalan tadi tu.
Ya, yang dalam kotak merah pertama tu, yang kita tak bezakan Z lagi tu.
Oh, okey. Faham.
Faham Okay.
Terima kasih doktor.
Sama-sama. Lagi. Daniel. Darren, are you there, Darren?
Yes, doctor.
Darren, I have to pair you, only 2 of you in one group. Is it okay for your project?
Yes, I'm okay.
Okay. If you have any problem, contact me. Okay?
Okay, doctor.
Alright. Okay. Yang lain boleh
Boleh doktor, terima kasih.
Boleh.
Sama-sama. Okay.
Terima kasih doktor.
Sama-sama. Kita jumpa Isnin depan ya. Isnin depan.
Thank you,
Okay,
Doktor.
doktor.
Okay,
Bye.
bye.
Doktor.
Bye-bye.
Bye, doktor.
Bye.